Okay, so here we are with a new Relearn packet, and as always, I'm going to go through the section A and explain all the questions as best I can, note some things that I might have seen commonly wrong with some questions, and then you need to do the next two sections, section B and section C. Now, with section B, do not do section C until after B is done. I want to see it, I want to check it, make sure you're doing things right. Then you can go on to section C. All right, let's see here. The first question, the cost of airing a commercial on television is modeled by this function. The cost of N commercials, C of N, is 110N plus 900, where N is the number of times the commercials aired. Based on this model, which statement is true? The commercial costs $0 to produce and $110 per airing up to $900. The commercial costs $110 to produce and $900 each time it's aired. Well, remember, N is the number of times that it's aired. Commercial costs $900 to produce and $110 each time it's aired. That's the right answer. And choice 4, 1010 to produce and can air it unlimited amount of times. Why is choice number 3 the correct answer? Because if we go in and we look at this, 110N means you're going to multiply 110 times the number of times that the commercial is aired. So which choice says that? It says here 110 each time it's aired. So that's the only choice that says that. And then it's $900 to produce the commercial, so that's why it's an extra $900 added on top of that. So the correct answer is choice 1. You know, I recently went through all of the Regents exams and I chopped them up by subject matter. And it seemed to me that of all of the questions that can possibly be on your Regents, the one that's been on there the most every single year, worth 2 points, is a question just like this. So being able to, being able to interpret a function and what each part makes up, like the 900 being the cost to produce it and the 110N being the cost to air it given N number of times, is a very important skill to get down pat. Okay. Next, the graph below represents a jogger's speed during her 20-minute jog around the neighborhood. Notice a couple of things. When I would do a question like this or answer a question, I'd want to just take a quick peek and make sure I looked at what the axes say. It's time across the bottom, and this is very important here. It's speed going up and down. So which statement describes minutes 9 through 12? Well, here is 9 through 12. And there's a tendency to want to put down, and I saw this on several students' papers, there's a tendency to want to put down that she's standing still. And if you notice, that's choice 1. They're trying to get you to bite on that choice. She's not standing still, even though the line appears level. See, if this was distance, then yes, she would be standing still because her distance is not increasing nor is it decreasing in this interval from 9 to 12 minutes. But it's not distance, it's speed. Since it's speed, it means she's maintaining a steady speed of 6 miles per hour. So that's choice 4. Staying at a constant rate. So just remember on that question that it was very important that you read the left-hand axis to realize that it was speed and not distance. Which table represents a function? Now, the big thing you have to remember about a function is that a function, for every input, there's a unique output. There's only one output. You can't have 2 different outputs for one input. And remember, x is input and y, or f of x, is output. So do you see how 2 here goes to a 3 and a 7? Well, that means that the number 2 has 2 different outputs. It can't be choice 1. If I go over here and I look at choice 2, 0 has 2 different outputs. It can't be choice 2. If I go here and look at choice 4, again, 0 has 2 different outputs. It can't be choice 4. But let's look at choice 3. I get a 3, a 5, a 7, and a 9. And each one has its own output. I don't care that some of the outputs repeat, that the 2's repeat and the 4's repeat. It doesn't, all the outputs don't have to be unique. It's just that every input can have only one output. This would be a function, 1, 2, 3, 4, and then 5, 5, 5, 5. That's fine, as long as the inputs only have it. Now, the minute I put a 5 here and let's say 6, and then a 6 and a 6, now we have a problem because, actually that's not a problem yet, I'm sorry. I'm going to put another 5 and a 7. Now we have a problem because there are two 5s, and the 5s have two different outputs. So that's a little sloppy, but here's the big thing. If a domain element, domain is the set of inputs. If a domain element like 5 has two different outputs, it's not a function. Like 0 has two different outputs, it's not a function. Like 0 has two different outputs, here they are, it's not a function. Like 2 has two different outputs, 3 and 7 in choice 1, not a function. Okay. Next up, Morgan can start wrestling at age 5 in Division 1. He remains in that division, and his next odd birthday when he is required to move up to the next division level. So on the day he turns 7, he has to move up, and he's no longer considered in the 5-year-old division. So look, here, well, let's look at one that doesn't work. Let's look at choice 3. He starts here on his 5th birthday. On his 7th birthday, it says he's in the 5th division because the circle's filled in. And he's in the 7-year-old division. You can't be in, or I'm sorry, Division 1 and Division 2. You cannot be in Division 1 and in Division 2 at the same time, so choice 3 doesn't work. Choice 4 doesn't work because if you notice with these open circles, on his 7th birthday, he's in neither division, so that can't work. If I look here at choice 1 or choice 2, this means, first off, he doesn't even start on the day he's 5 years old because it's an open circle. And then on the day he turns 7, according to this, he stays in Division 1 because that's filled in. And only after he's 7 years old does he move up to Division 2. And that's not what it says here. It says until his next odd birthday when he is required to move up. Now let's take a look at choice 1. He's going to stay in here, stay in here, stay in here, stay in here. Now he hits his odd birthday. He's no longer in that set. That's why it's an open circle. He jumps up, and now he's in Division 2 until his next odd birthday. Then he jumps up. Now he's in Division 3 until his next odd birthday. Then he jumps up, and so on. So choice 1 is the correct answer for this guy. Everything we've done so far is interpreting functions. Now, number 5, we didn't do a lot of work with this, and I thought that this would give kids a hard time. But we're going to test it now. We're going to do the Relearn packet with it. We're going to put it on the next test. We're going to do a lot of work with this so that by the time we hit the Regents at the end of the year, a question like this is second nature to you. The graph of the function f of x is equal to the square root of x plus 4 is shown below. So it's not like you have to figure out the graph. They're giving it to you. Now they want to know the domain of the function. Which letter is domain? Is x domain or is y? It's x. So what I like to do is draw down the graph and see what part of the x-axis is covered. So the x-axis is going to be covered all the way up to, now it's a closed circle, so including that point. So this is the x part, and since this arrow goes on forever, so does the domain go on forever and ever. So the smallest x value in this domain is right here, and that value is -4. So I want x is greater than or equal to -4. Choice 2. It's not greater than because the closed circle meant I was allowed to equal it, so I have to have a greater than or equal to symbol there. If it was 0, like choices 1 and 3, then my graph would have looked like this, and it would have started here at 0. But it doesn't. It starts over here at -4, so therefore it has to be choice 4. What are the zeros of the function x squared minus 13x minus 30? I think just about everybody got this right, but in case you didn't, the first thing I would do is graph it. Later in the year you'll learn another way to do this, but for now the best way to do it is to graph it. And once you graph it, you can then look at the table or the graph itself. And you want to find what are the x values when the y value is 0. Or on the graph you want to find where it crosses the x-axis. So what are the x values here? And what are the x values both when y equals 0 and when it crosses the x-axis? If you do that, you will find that as choice 4, 15 and -2. All right, just if you weren't able to do that, do it on your calculator now and you'll see that. Okay. Okay, next one, number 8. Laboratory technicians studied the population, the growth of a colony of bacteria. He recorded the bacteria every day as shown in the table. Which one will be the technician's data? Well, I can tell you right away that these two are going to not work because the problem is if I do 25 times 4, I don't get anywhere near 9 million. So that's not going to work, or 25 times 5. So the question is it choice 1 or is it choice 2? Now, what is anything to the 0 power? Because this is t, time. Anything to the 0 is 1. So if I do 25 to the 0, it should have said 1 here. So clearly it can't be choice 1. So this arrives to choice 2. And let's plug in the values and see if it works. Here, what's 0 plus 1 is 1, and 25 to the first is 25. So that checks. Let's plug in a 2. 2 plus 1 is 3. 25 to the third, it's 625 times 25, which I guess is 15,625. And it will also check for the fourth one. So, therefore, choice 2 works. So when you get a question like this which says which function rule works, the idea is to plug in the values into each function rule, choices 1, 2, 3, and 4, and see which one checks. But you can eliminate choices pretty quickly just by having a reasonable estimate kind of I, and just cross out ones that won't possibly work. Number 9. If f of x is 3 to the x and g of x is 2x plus 5, for which value of x is f of x less than g of x? Well, I would do the same thing. I would plug them in. So if I plug in a -1, I'm going to get 3 to the -1, and over here, I'm going to get 2 times -1 plus 5. Now, 3 to the -1, negative exponent, it's 1/3. 2 times -1 is -2, plus 5 is 3. Well, clearly, 3 to the -1 is less than 2 times -1 plus 5, so the right answer will be choice 1. If you substitute in all of the other values, okay, you'll find out that f of x works out to actually be greater than g of x. For which value is f of x less than g of x? Yeah, absolutely. That's the way it would work. Okay? So choice 1 is the one for which that's true. All right, so now we go to, and again, just like before, number 9 was a matter of testing the choices. Now we go to our graph. And this was meant to be a nice, easy question on the test. And I don't know how easy it was for you or how easy it was not. But if you're not getting this right, we've done a lot of these. And I don't want to sound harsh, but by this point in time, you should be getting it right. And you're the problem if you're not getting it right, because you've had more than enough opportunities to get it right. You need to prepare better. There are some hard questions on here. This is not one of them. X, Y, and Y is the same thing as f of x. So you would plug this into your calculator, and the calculator would give you the table. I'm actually going to do the table off the top of my head right now. 1, 0, -2, 2, 3, 4. Hopefully that's enough in each direction. If I plug in a 0, I get -3. If I plug in a 1, I get -4. If I plug in a -1, I'm going to get 1, 0. Good, it will be enough. And -2 would be 5, and then this will be -3, 0, and 5. And then I plot the points. -2, 5, -1, 0, 0, -3, 1, -4, -3, 0, and 5. We're always looking for that symmetry. When we graph a parabola, it's a parabola because the highest exponent is squared. That's a little sloppy, but there it goes. Okay. So once you have the graph done, and the graph was worth 4 points, and then it was 2 points for each of these guys. I think it went something like that. The zeros are wherever it crosses the x-axis. In this case, it crosses at -1 and 3. You could also notice them here, here, but just put the x value down. Don't also put the 0. So it's -1 and 3 are the zeros. The vertex is the coordinates of the turning point. The coordinates of the turning point are right here. It's +1 and -4. So the vertex is +1, -4. And the axis of symmetry is the line that runs right down the middle of the graph. Axis of symmetry always begins x equals, because the axis of symmetry for our purposes is always a vertical line. If it's a vertical line, all vertical lines are the only lines that begin x equals instead of y equals. And what does x equal? Well, x is going through -1, right? Oh, +1 right there. So it's x is equal to +1. All right, and there's my graph done. I'm not going too nuts with this because in all honesty, you should be really good at it. Plug it into the calculator, that generates your table. You should write this table down, okay? And then once the table is written down, plot the points. Some people are still not plotting the points. Be very careful to actually physically plot the points on the table. If you put the table down here and list it, I think you then plot the points and it works out very easily for you. If you don't list the table, students' graphs are tending to come out very sloppy and they're losing points for those. Okay, next up, Alex is selling tickets to a school play. An adult ticket costs $6.50 and a student ticket costs $4. Alex sells X adult tickets and 12 student tickets. So if he sells 12 student tickets and each one costs $48, then altogether he's collected $48 for student tickets. Write a function to represent how much money Alex has collected from selling tickets. F of X is equal to, now each ticket that he sells for an adult is $6.50. So $6.50 times each adult ticket, that'll give you the amount there, plus $48 based on the student tickets, because 4 times 12 is 48, and there's my function rule. Most people did get that right, okay? Pretty straightforward. And again, every time you see, almost all of the questions we've done so far, we're taken off of old Regents exams. Oh, and here we go. This is a piecewise function. It's a piecewise function because the domain, if the element of the domain that you're looking for is between 0 and 40, you have to follow the first rule, which is 10 times the value you're given. If the value is greater than 40, you need to follow the second rule, which is kind of complicated here, 15 times x minus 40 plus 400. So it says determine the difference in salary in dollars for an employee who works 52 hours versus 38 hours. So let's do 38 hours first. We'll do that in red. 38 hours. 38 is between 0 and 40. So I'm going to plug a 38 in for x, and I get 38 times 10 is 380. And that would be the amount of money that someone who works 38 hours would make. Now let's consider how much money someone who works 52 hours would make. 52 is greater than 40, so I use this bottom equation. And I'm going to get 15 times 52 minus 40 plus 400. 52 minus 40 is 12. So I get 15 times 12 plus 400, which is 180 plus 400, which is 580. But at the end of the day, in this problem, it says determine the difference in salary. So if the person who works 52 hours makes 580 bucks, and the person who works 38 hours makes 380 bucks, the difference in salary is $200. Okay? So again, this is a piecewise function. These are pretty popular on the Regents. And as you notice, even today, as I'm doing this, today's lesson was to work on piecewise and graphing them a little bit. So we do want to keep coming back to these and spiraling and scaffolding them into our work. Those are education buzzwords. Okay, let me put this up on the internet, and then we'll start number 2.